Chemistry, Mrs. KJ here, going over lesson 4.02, Polyatomic Ions. So what does poly mean? Poly means many, so we're going to have many atoms together that make up an ion. What does an ion mean? It has a charge. So polyatomic ions are made of two or more atoms. In this lesson you will learn polyatomic ions, groups of atoms that are bonded together and act as a single ion. You will study how the electronegativities and ionization energies of interacting atoms can help determine the types of chemical bonds they form. So polyatomic ion is composed of two or more atoms with an overall positive or negative charge. It's composed of two or more atoms that have small differences in electronegativity and ionization energy. In other words, the two atoms that bond together are going to pretty closely both have the same electronegativities. You remember what that means? That means that they both really want to gain electrons. And they both don't want to lose the electrons. So if they both want to gain electrons, what are we going to do? Well, they're going to end up sharing. So again, if you want the student guide, you need to go into the lesson to get it. Goals are identify some polyatomic ions, explain how electronegativity relates to bond formation, explain how ionization energy relates to bond formation. Explore polyatomic ions. Polyatomic ions contain more than one atom. Monatomic ions contain only one atom, but sometimes several atoms join together and act as a group. When this group has an overall charge, it is called a polyatomic ion. An ion composed of two or more atoms bonded together with an overall charge. So go ahead, hit pause, copy down the definition into your notes. Poly means many, so polyatomic ion is an ion with many atoms. For example, nitrate ion, NO3-. So the overall charge is what? -1. And you can see that there's one atom of nitrogen and how many atoms of oxygen? You can see it by the subscript, or of course the picture. You can see there are 3 oxygens. The atoms as a group are considered a polyatomic ion rather than a molecule if they bear a net or total charge. They bear a net charge because the total number of protons of the atoms involved does not equal the total number of electrons. So how would we compare protons to electrons? Are there more or less electrons? Well, it's a -1 charge, so there's one more electron than there are protons. Polyatomic ions can be either cations or anions. However, there are only a few polyatomic cations and many more polyatomic anions. And you have a cheat sheet of polyatomic ions. So if you didn't print it yet, make sure that you do. And this is what it looks like. You can see the formula, you can see the charges. See how it's 3-? You can write it either way, 3- or -3. I tend to write it -3, but one of the formats of doing it is 3-. So, and then it has the name. You don't have to memorize these because you can use this cheat sheet on all tests and quizzes. A polyatomic cation is a group of atoms that has an overall positive charge. Remember that the hydrogen cation H+ is always associated with other atoms because otherwise it would just be a free proton. Water, H2O, is a molecule with no charge, so it's neutral. When combined with H+, it becomes the polyatomic hydronium ion H3O+, so it has a +1 charge. A similar case is the ammonium ion, which is NH4+. So what's the charge of ammonium ion? +1. How many atoms of nitrogen are there? 1. How many atoms of hydrogen? 4. But now that it's a polyatomic ion, you treat it as one thing. You have to keep it together. It too is a polyatomic ion. It is like the molecule ammonia, which is NH3, except that it has an additional hydrogen cation and of course the +1 charge. A polyatomic anion is a group of atoms with an overall negative charge. If a group of atoms has an overall negative charge, so they have extra electrons, it is called an anion. Look at the ions listed here. You may notice that they all have a negative charge. Therefore, they are all anions, but also notice that all of them are polyatomic ions. Most of these ions contain at least one oxygen. And I'm not sure why it's not loading, so we'll just look at our list. And you can see the same thing. Most are negative. They pretty much almost all contain oxygen. There's a few that don't, but really the most common ones almost always contain oxygen. Although polyatomic ions can form from many types of elements, there is a large group of polyatomic ions called Oxy Anions. Let's break that word apart. What do you see? We see oxy, which stands for oxygen, and we see anions, which are a negative ion. So they're negative ions that contain oxygen. So make sure you write that down. Oxy anions are polyatomic ions that form between an atom of one element and different numbers of oxygen atoms. What I would write down is oxy anion equals a polyatomic ion that is negative and contains oxygen. These polyatomic ions are very common. You have probably heard of some of them, such as sulfate, SO4, which actually has a -2 charge, sulfite, SO3, -2 charge, phosphate, PO4, -3 charge, and carbonate, CO3, -2 charge. Note that differing numbers of oxygen atoms in the oxy anion change the charge of the polyatomic ion as well as the name. That's true, but there's some exceptions, so really you're better off just looking at the list. All right. And by the list, I mean the one on the cheat sheet that I gave you guys, because I don't like what they said, because look at this. All the sulfate, sulfite, thiosulfate, I mean, they have different numbers of oxygen, but they have the -2 charge. So yes, it matters, but it's also an indirect relationship, so not the best. Electronegativity and ionization energy are important factors in forming chemical bonds. So if you forgot what they mean, hit pause, write them down. Electronegativity is how badly an atom wants an electron. Ionization energy is how much energy it takes to get rid of an electron. As you learn in studying the periodic table, every element has a value of electronegativity and ionization energy. Electronegativity, the ability of an atom to attract electrons when the atom is in a compound. Ionization energy is the energy required to remove a valence electron when the atom is in the gaseous state. Basically, these factors determine how well an atom holds on to its valence electrons and how easy it is to strip an atom of a valence electron. Atoms with low electronegativities and low ionization energies tend to lose their valence electrons and do not attract electrons from other atoms. So on the periodic table, which ones are they talking about? They're talking about like the metals here, right? They don't want to gain electrons, they want to lose them to get their full outer shell and be stable. On the periodic table, both electronegativity and ionization energies increase from the lower left to the upper right. So we can look here. The high electronegativity is in the purple, and the low is over here. And then, of course, you have the noble gases, which really aren't going to do much of anything. Now, if you're like, oh, but wait, krypton, yeah, there's some exceptions. We basically don't deal with these at all in this class. All right. Atoms with similar electronegativity and ionization energies tend to form polyatomic ions. Okay, now they reverse the colors. I don't know why, they just did. So low electronegativity means that they do or do not want electrons. They do not. They do not want to become more negative. Nope, nope, nope. They want to be more positive. They want to get rid of their electrons. So over here, the nonmetals are the ones that are going to want to gain electrons. Atoms with similar electronegativities and ionization energies unite with other similar atoms by sharing electrons to form polyatomic ions. Okay, sharing. This is big. We're not gaining and losing. We're sharing now. So we talked about how carbon's going to share because carbon has how many valence electrons? 4. So gain 4, lose 4, it's the same, so they just share. But now the nonmetals are also going to share electrons with each other. So we have nothing to do with the metals now, because a metal and a nonmetal made an ionic compound. Now we're making a polyatomic ion, so we're only dealing with nonmetals coming together and sharing because they each want more. Well, if they both want more, one of them can't give some up. The only thing they can do is share them. For example, the electronegativities and ionization energies of nitrogen and oxygen are similar. So each type of atom holds on to its own valence electrons while attracting valence electrons from the other. So it's like, hey, come here. Okay, that's great. I want to come over by you, but I'm still staying with who I started with. That's why they share. The atoms tend to share electrons, forming the polyatomic ions nitrate, NO3-, or nitrite, NO2-. You don't have to memorize the names, but I always found it was easy because ate, like eating, it ate more oxygens. Nitrite, it's like the light version, light nitrite. It has less oxygens. So those are the most common endings for polyatomic ions, ate and ite. Remember, if we would name a compound and it ends in nitrogen, it would be ide, I-D-E. So ide is a compound, ate and ite are hints that you have a polyatomic ion. Interacting atoms with large differences in electronegativity and ionization energy tend to form monatomic ions. Atoms with very different electronegativities and ionization energies will not share. So like for example, our metals and our nonmetals, they're not going to share. Electrons will move from one atom to another, forming ions out of each atom, but not forming polyatomic ions. So if we look at table salt, Na becomes +1, chlorine becomes -1, but they're an ionic compound. +1, -1 equals 0. Overall, it's neutral, even though the sodium end of it is positive and the chlorine end of it is negative. Large differences in electronegativity and ionization energies of interacting atoms thus lead to monatomic ions. The low electronegativities and ionization energies allow the atoms to exchange, so give and take, electrons instead of sharing them. So when they're far apart, they're going to give take. We've already talked about that. Polyatomic ions are going to share because they each want more, and they're not going to give any up. It's easy to predict the type of bonds and ions formed when atoms interact. You can look at each atom's position on the periodic table to get a sense of its electronegativity value and ionization energy. Based on its position, you can predict the type of bond and ions formed by the atom. The interaction of sodium atoms and fluorine atoms can serve as an example. I would prefer chlorine because then it's table salt. Look at the periodic table and find sodium and fluorine. All right, so sodium, fluorine. We have a metal and a nonmetal. That should be your instant thing that you know it's going to be an ionic bond. But again, we can go over the why. Sodium has a much lower electronegativity and ionization energy values than fluorine does. So compared to fluorine, sodium holds on to its valence electrons weakly. It doesn't want them. Also, fluorine will attract valence electrons from sodium. As a result, sodium and fluorine atoms will likely exchange electrons in that sodium will give up its valence electron for a +1 charge to fluorine to give it a -1 charge. Sodium and fluorine, therefore, will not form polyatomic ions. They will form ionic compounds, which you already know. Hydrogen, of course, is an exception. Its position on the periodic table is not related to its electronegativity and ionization energy. Nitrogen and hydrogen combine to form ammonia, a neutral compound, NH3, and the polyatomic ion ammonium, NH4, with a +1 charge. But nitrogen and hydrogen are far from each other on the periodic table. Why do they form polyatomic ions? Because hydrogen is really a what? A nonmetal. So two nonmetals coming together are going to have, when they're sharing the electrons with the charge, are a polyatomic ion. Here is an instance where merely looking at the periodic table can be deceptive. It's pretty much the only time it can be deceptive. But remember, it's a nonmetal, so it's really not that deceptive. It seems as though hydrogen would tend to form monatomic ions, but in reality it is less likely to give up its electron because of its electronegativity and ionization energy. And again, it's a nonmetal. That's the part you got to remember. And the energy values are closer to those of the elements in group 7A, such as fluorine and chlorine. Polyatomic ions form from two or more interacting atoms. Polyatomic ions are made of what? Metals, nonmetals, what? They're made of nonmetals. What do they do with their electrons? Exchange or share? They share. Do they have a charge? Yes. So nonmetals sharing electrons with a charge. Polyatomic ion consists of two or more atoms that interact via valence electrons and bear a net or total charge. Polyatomic ions can be cations or anions, although there are a lot more anions than cations. Oxy anions are polyatomic ions that form between an atom of one element and different numbers of oxygen atoms. And are they positive or negative? They're negative. I'm going to run out of time, so hit pause and read the last paragraph and go over this yourself. Big thing in this paragraph, remember, metal, nonmetal makes an ionic compound. All right, when you're done reading this one on your own, That's it.